my computer screen and my voice.
Our voices?
Your voices, if you're loud enough, yes. All right. All right, guys. We are continuing. This is kind of a warm-up. This is from yesterday's notes on worksheet. What did we just say again? Okay, whoops, turn this on, turn this on. Okay, 6B, here we go. Anybody notice anything about this? Yes, they are the exact same thing. Now, is this distributing?
No.
Okay, let me ask you this question. Does this mean sine times x? No. This is the sine of x, which is a function, okay? So, while there are two exact things, we are not distributing and doing crazy business, but we can say there's one of these plus another one of these, so there's two of these. Now, we were doing sum and distance formula yesterday, so we're going to use that again, but first I think it'd be faster if we just divided by 2. So we'll have the sine of pi plus x equals 1/2. Now, go to your gray sheet and tell me what the sine of a plus b expands to. Sine a cosine b, which in our case is x, plus cosine a, which is pi, times sine of b, which is x. Okay, what do you think we should do next? Sine of pi is 0. Cosine at pi is -1. So what does all that simplify down to? Oh, yeah, what happened? That's supposed to be an x. You guys are... That was supposed to be an x, both those places. Okay, this is 0, so we have -1 sine of x is 1/2, which means the sine of x is -1/2. Can I skip to that? Everybody okay? Okay, it says 0 to 2 pi, so we look at our handy-dandy unit circle, and where is that true? Sine is -1/2. Not 5 pi over 6. We're doing sine, right, guys? Sine is negative in quadrants 3 and 4. Everybody good? All right, so that was an easy one. This is an even easier one, because I'm going to tell you we can cross it out. Not going to do any tangent ones. Which brings us to this one. Can we just add these and say 2? Yeah, they're not the same. One is a plus b, and one is a minus b. Okay, this is not hard, but it's just kind of long. We need to expand these. Can somebody tell me what sine of a plus b trades for? Sine a cosine b, then what? Plus cosine a sine b. Everybody doing this? This is on worksheet 6B. Now we have sine A minus B, which is sine of A times cosine of B, and the B is just the pi over 3, minus cosine A sine of B equals 1. Almost ran out of room. Okay. Something goes, oh yeah, this is an X again. Okay. Something goes away. This one is negative. Where's the one that's exactly the same? This guy, right? So what we have left is this and this. They are the same, so what could we write? 2 sine x times, I guess I will write it cosine pi over 3. We're going to trade that out, but I don't want to skip too many steps. What is the cosine of pi over 3? Okay, then what? I have 2 times the sine of x times a half equals 1. Yep, so we just get sine of x is 1, which is true at pi over 2. That's it. Wasn't that fun? Okay. All right, so remember yesterday we did, I don't remember, I think I did number 5 on the board and told you could take a picture, but you can just cross it off. I don't care, whichever. Everybody got that? All right, now we are moving on to today's lesson. That was our warm-up. Today's lesson is 5.5. It says multiple angle and product to some identities is the title of the section in the book, but we're just going to basically use the double angle and half angle formulas. Can anybody find those on your gray sheet? There's a whole bunch of them. Do you see it? The whole bottom third of the sheet, right, is double angle relations and half angle relations. All right. The first thing we're going to talk about is double angle identities. For sine of 2 theta, there is only one trade possible, and it is a very, very, very important one that you should memorize. It's not that hard. Okay, sine of 2 theta is 2 times the sine times the cosine. 2 sine cosine is equal to sine of 2 theta. All right, over here, there are actually 3 choices the same. Okay, cosine of 2 theta has 3 different choices. Anybody see where those might come from? If I took this first one and I substituted for cosine a 1 minus sine squared, then I'd have 1 minus 2 sine squared, which would be this one. If I took the first one and in place of the sine squared, I put a 1 minus cosine squared, I'd have this one. Okay, so these are just trades for this one. But when you are solving for cosine of 2 theta, you can use any one of those you like. All right, tangent 2 theta, once again, looks complicated. Okay, I need to make this clear that the tangent of 2 theta is also equal to the sine of 2 theta divided by the cosine of 2 theta. Just like sine or tangent is always sine over cosine, as long as those 2 thetas are all the same. The reason for that is, the reason I want you to make that clear to you, we can always use this formula, but if we've already found the sine of 2 theta and the cosine of 2 theta, then just dividing them will save us a bunch of messiness, okay? All right. This is a really nice example. You don't have to write anything down. If you just look up here, this indicates what quadrant am I in. Between pi and 3 pi over 2 would put me in quadrant 3. The sine is 7/25, opposite over hypotenuse. How'd they get this 24? Pythagorean theorem. But if it was my picture, I would have put the negative right on the 24. Okay? So we're at a point right now where we know the sine of this angle is what? They actually told us that one to start with, right? It was negative 7/25. There's a negative there. All right. The cosine of this angle is what? Negative 24/25. And the tangent of this angle, if we wanted to go there, is 7/24. Okay. Then what they did to find the sine of twice that. Now, I want you to picture the number for theta is something that takes it into the third quadrant. So it could be 200. Would that work? Would 200 be in that quadrant? Okay. I don't know that it's 200, but something took it into that quadrant. 2 theta means we're going to double it. So we're talking about finding the exact theta of twice that size, like 400 or something. Okay? Just so you understand that 2 theta is the size of the angle has been doubled. All right, to do that, you do the substitution, 2 sine cosine, and you put the values in and you simplify it down. Cosine of 2 theta, they use this one. I don't know why they chose that one out of the 3 trades you can make. And then they put the value that we found up here for cosine in and simplified it down. All right, we're going to do one in a minute, so I'm not going to go through it too extensively. But then for tangent, they said, well, we could put all those values in and simplify that mess. Or if this is the sine and this is the cosine, can we just do y over x? And remember, when you flip everything over, the denominators will cancel. We end up with 336 over 527. I kind of like method 2. I don't know about you. Rather than having to simplify that mess when you're finding tangent. All right, here we go. You have these on your sheet. Which one are you going to memorize? Okay, this guy right here. All right. This particular one says we're in what quadrant? Between 0 and 90 means we are in quadrant 1. It says the sine is 1/4, so where am I going to put the 1? Horizontal side, vertical side, oblique side. Vertical over here, right? Up and down. Opposite over hypotenuse. Okay. Have to do Pythagorean theorem. How do I find this side down here? Yes, it's 1 squared plus that x squared equals 4 squared, which would be 16 minus 1 square root of 15. Everybody okay? All right. Before we go any further, it's really helpful if you have written down somewhere what the sine and cosine are, because we're going to substitute those in. So the sine is 1/4 and the cosine is what? Cosine is square root of 15 over 4. Okay, that goes here. Yes, I put a blank there, sorry. All right, so sine of 2 theta is 2, just the number 2, times the sine value, which was 1/4, times the cosine value, which is square root of 15 over 4. That winds up 2 square roots of 15 over 16. And the 2 and the 16, the guys outside here multiplied, can be reduced to just square root of 15 over 8. All right, ready to try one? Totally on our own? Okay, what quadrant are we going to draw this in? Pi and 3 pi over 2. So we're in the third quadrant. What information do they give us? Tangent is 4/3. That's the y over the x, right? The y is 4 and the x is 3. Almost. They're negative because of the quadrant. Good job. Hypotenuse or radius is 5. All right, so what are the sine and cosine of theta? In other words, the angle that took us all the way around to here had a sine of what? -4/5 and a cosine of -3/5. They had already told us the tangent up here. All right, so we are to find sine of 2 theta. What's the trade for that? 2 sine times cosine. Okay. What is the sine value for this angle? Guys, this is not difficult. Just plug them in. -4/5. The cosine is -3/5. Remember, this is 2 over 1 if that helps you. On the bottom, I have 1 times 5 times 5 is 25. On the top, 2 times -4 times -3. Anybody? 24/25. Cosine of 2 theta. Who would like to make the magical decision? They all three give us the same answer, but there are 3 choices we can use. Cosine squared minus sine squared. That's the one I usually use. All right, we're going to put in the value of the cosine and the value of the sine. What are those numbers? And the sine. Okay, when I square those, I get 9/25. Be careful. Squaring top and bottom, and a negative becomes a positive. Minus, square this guy in this parenthesis, and I get 16/25. So what happens when I subtract? -7/25. Is everybody okay? All right. The tangent, we're also supposed to find the tangent of 2 theta. Does anybody remember the shortcut I talked about? We can just take sine of 2 theta over cosine of 2 theta. So we have 24/25 is divided by -7/25, which will become what when you flip it over and cancel some things? -24/7. Do I need to write out what I canceled? How that worked? You just flip this one over, 25 over -7, then the 25's cancel. All right, can anybody tell me what quadrant 2 theta lies in? The sine is positive, the cosine is negative, and the tangent is negative. Quadrant 2. Does everybody understand what I'm saying? Because the sine of this doubled angle was positive, the cosine was negative, and the tangent was negative. When we doubled the size of that rotation, and it wound us up over here somewhere in quadrant 2. By the way, my example was 200. 200 doubled would be 400. Would that be in quadrant 2? No. So this angle must be bigger than 200, must be further into that quadrant. Okay? Is 250 in this quadrant? 250 would be in this quadrant. Doubled would be 500. Take 360 away and we get what? 140. Would 140 put us in quadrant 2? Yeah. So 500 might have been, or 250 might have been a better estimate for our angle. Anyway, okay. Just trying to get you to see how this works. All right. This is a really sweet solving problem that we would need to use a substitution for. Just look up here for a minute. We don't know how to do this yet, right? We did some double angle ones. Yes. Yes. We did some double angle ones where we did U substitution and we had to divide everything by 2 at the end. Okay? But we can't do that here because we have a sine and a sine 2 theta. What can I trade this for? I'm supposed to know this one. 2 times sine times cosine. Okay. Minus sine is equal to 0. What do we want to do now? Ladies, pay attention. What can we take out of everything? Okay, what will be left? 2 times cosine and a minus 1. Okay, now what? Either, oh, no. Don't divide because you will lose half of your solutions. Okay, the cosine is 1/2 or the sine is 0. So check out your unit circle. It says between 0 and 2 pi in the directions. Where's the sine? 0? 0, 2 pi, and 1 pi, right? Isn't the sine 0 at 0 and pi? Okay. And where is the cosine? Positive 1/2. Pi over 6 and, no, the cosine is at pi over 3. That was sine, sorry, my bad. Pi over 3 and 5 pi over 3. Okay, we did get the same 4 solutions as they did, thankfully. All right. The next section on the notes is called the power reducing identities, or actually, I don't know if it's up at the top somewhere, but you have these identities. Can you find these on your unit circle sheet, on your gray sheet? They are on there. They are in the lower right-hand corner. The very bottom right-hand corner. Do you see them down there? Okay. There is a typo. That third one from the bottom should be tan squared of theta equals 2 tan over 1 minus tan squared theta. I don't really think we're going to use that one. But it should say tan squared. But they are down there, okay? By the way, is that the same tan squared that we have on this sheet? It's a different one. Like I said, I don't think we're going to need them, but all right. We don't use those very often. We're going to use they used it to do this problem when they did the work, and I'm not going to. Again, I don't think you have this. Okay. Help me out. What could we trade here? Because we don't want a 2 theta. We could do cosine squared minus sine squared. Actually, that would be okay if you did cosine squared minus sine squared because it's minus. So then the cosine squareds would go away, right? Otherwise, I was going to trade it for, what is it, 1 minus 2 cosine squared or something? No, then what's the other one? 2 cosine squared minus 1? I was going to make them all cosines, was my point. But it'll be the same thing. So whichever way you want to do. What was the one I said? 2 cosine squared minus 1? Did I say it in the right order? Okay. I would have gone with that one just because I wasn't introducing something, a function that wasn't as part of the problem already. All right, if I distribute the negative, I get, okay, 1 minus 2 is negative 1 cosine squared, but what else is over here? Plus 1 equals 1/2. If I subtract 1, change the signs on both sides or divide by negative 1 and I get cosine is 1/2. Cosine squared is 1/2. Yikes. But what happens when I square root that? Plus or minus. Square root of 1 is 1. Square root of 2 is square root of 2, which rationalizes. Okay. Everywhere that's true. Guys? Some of you are... Okay. Pi over... Or square root of 2 over 2 is at all the fourths, right? All right. That wasn't so bad, was it? All right. These are very important. These are the half angle identities. Somehow I didn't put them on your notes. Somehow I got excited and tried to make the notes one-sided. They didn't have a chart. I would have had to copy it out of the book, but these are important. But the bottom line is you're probably not going to ever look at your notes, but you may keep this reference sheet around for a while, right? And they are on the reference sheet where? Bottom right. Okay? Now, the plus or minus we're going to talk about. Okay, that plus or minus is really important on those three. We will get to discussing that in just a minute. It says to determine the sign, whether it is the plus or the minus. It's only one, it's not both. You have to determine what quadrant theta over 2 would lie in. So if theta divided by 2 was in quadrant 2, or let's say theta was in quadrant 2. When you cut a quadrant 2 number in half, it's going to put it in quadrant 1. So then it would be plus instead of minus. And we'll talk more about that because it's a little tricky. Cutting a quadrant 3 angle in half would put it where? Quadrant 3 is what in degrees? Quadrant 3 means it's somewhere between 180 and 270. If you cut those in half, you get 90 to 135, which means it's in quadrant 2. I really have to think about this. I always write it out. If it's in quadrant 4, the original angle, it's between 270 and 360. When I cut that in half, I get what? Which also puts it in quadrant 2. Okay, so we'll just think about it when we get there. All right, here we go. All right, we're going to do a couple of these crazy ones just so you can see how much fun they are. I'm not going to put one on our test or quiz. What is this half or double of? Yes, the sine of 45 divided by 2 would be the sine of 22.5. Everybody okay? So we are using the sine of theta over 2 to solve this. Find it on your sheet. What's the trade for sine of theta over 2?
Plus or minus square root of 1 minus cosine theta divided by 2.
All right. And we're using theta to be what number? No, after we divided by 2, we got 22.5. So theta was actually 45. Okay, this is 45. So, okay, let's determine the plus or minus right now. 45 divided by 2 is 22.5. We are in quadrant 1, so everything is positive. So it's just plus, or you can leave it off altogether. 1 minus the cosine of 45 divided by 2. What's the cosine of 45, guys? 1 minus square root of 2 over 2, all divided by 2, all under a radical. Did that make you want to cry a little bit? Okay. Very important issue for calculus is that you recognize to get rid of what's called a complex fraction, fraction within a fraction, you could multiply top and bottom by common denominator. If I multiply top and bottom by 2 here, distribute it to the top, and what will I get? 2 minus the square root of 2, because 2 times 1 is 2. Square root of 2 divided by 2 times 2, those plain old 2's will cancel, and we'll just have a square root of 2. In the denominator, 2 times 2 is 4. Why is that good news? Yes. The numerator is the square root of 2 minus the square root of 2. So the square root of the quantity, 2 minus the square root of 2. But the denominator is square root of 4, which is just 2. Okay, this is the exact value. Aren't you glad you know that?
So it's okay to have a radical within a radical?
Yes, it is okay to have a radical within a radical. There's only way we could rewrite that would be to put fractional exponents. So there's not, it's one or the other. There's no other way. This was, the sine, was it sine or cosine? Sine of 22.5. So if we put our calculator in degree mode, type sine of 22.5, we'd get exactly the same thing as if we did that crazy business there. All right, we're going to try one more. Yes. Because we multiplied top and bottom by 2. Because we square rooted the 4.
Oh, okay.
I could write this as square root of 2 minus square root of 2 all over square root of 4, which is where that, yep. My square root was a little shrimpy there. Good question. All right. Let's do this in degrees because my brain works better in degrees. What is 11 pi over 12? 11 pi over 12? 11 times 180 divided by 12. It's 165. Okay. You might have been onto something, though. What is double this? So, this is the cosine of 330 over 2. Does that work? Okay, what's the rule for cosine of theta over 2?
Plus or minus square root of 1 plus cosine theta divided by 2.
All right. So 330 divided by 2 is 165. What quadrant would 165 be in? Quadrant 2. What is the cosine in quadrant 2? Positive or negative? So we're going to need a negative out in front of our parenthesis this time. Okay, the plus or minus never just gets to stay a plus or minus. You have to decide, is it a plus or is it a minus? When you're calculating values anyway. 1 plus. What is the cosine of 330?
Square root of 3 divided by 2.
How did we get this to look a little bit nicer last time? Common denominator, top and bottom. Anybody get what that will become? 2 plus the square root of 3 all over 4. So on the top, we have negative square root of 2 plus the square root of 3, all divided by the square root of 4, which is 0.02. Okay, I do hereby solemnly swear that will not be on the quiz or test. They're not that complicated. They're just, well, and they're not useful in my opinion. Okay, what is useful is a question like this. Sine squared equals 2 cosine squared of x over 2. All right, I'm just going to take you through this real fast. They traded this for its identity, and then they squared it, which just got rid of the square roots, right? And then there was a 2 out front, so that canceled. And they wound up with sine squared equals 1 plus cosine. Well, there isn't a trade for plain old cosine, but there is for sine squared. Became 1 minus cosine squared, a Pythagorean identity. Then they moved it all to one side, factored out the cosine, and solved. All right, so here's our last question on the notes, I think, isn't it?
Yep.
Okay. What can we do to this?
Change them.
Sine 2 theta can trade out for
2 sine times cosine.
all those things multiply to make 0. So the cosine could be 0. 2 could be 0. What do you think about that one? Sine could be 0. Cosine could be 0. Well, we got that one twice, and that one can't ever be true. So where's the cosine 0 or the sine 0?
Cosine and pi half and 3 has pi.
Okay, and the sine?
Sine. Yeah, 0.
So we have 0, pi over 2, pi, 3 pi over 2. We could include 2 pi, except it's a soft bracket. Okay, either x or y is 0 at all the quadrantial angles. Yes? Okay. On the back, I know I said that was the end of the notes, didn't I? It's the end of the notes on that side. I could leave you these, but I think I'd rather try some together. Because you got a bunch of worksheets. Oh, does 7B is part of your homework check? Oh, that was really nice of me. I think I did most of it with the last class. I don't have a problem with that. I don't know how far we'll get. What quadrant is this in?
No.
Pi and 3 pi over 2.
Negative.
It's pi and 3 pi over 2, and it says the sine is negative 3/5.
Oh.
Sine is opposite over hypotenuse. If I do Pythagorean theorem, what's x up here? It's 4, but it's negative because of the quadrant we're in. Everybody okay? So what are the sine and cosine for this angle?
No.
They gave us negative 3/5, so it better be right. The cosine is negative 4/5. We could write down the tangent. I don't think we're probably going to choose to use the one that has the tangent in it. What is the tangent of this triangle? 3/4, right? Positive 3/4. Everybody okay? Heard like 6 different answers there. All right. What's the trade for 2 sine theta? 2 times sine times cosine. Okay. So I'm going to put my values in. What's the sine? And the cosine? Okay. Remember that 2 is 2 over 1. So I get 24/25. Yes, this is almost the same as the exact problem on the front. It's not, actually. All right. Cosine of 2a. Which one do you want to use? There's 3 trades. Cosine squared minus sine squared. Okay. So we will have a negative 4/5 squared. What is that going to become? 16/25. I'm running into the problem below here. Minus the sine squared, which is negative 3/5. What is that when we square it? So 16 minus 9, 7. We keep the denominator, so it's 7/25, and that is the cosine. I should have done different color or something. Okay, tangent, we get to cheat. Tangent, we can just do sine over cosine. So 24/25 over or divided by 7/25 becomes what? 24 over 7. All right. sine of alpha over 2. Now what? What's the relationship we have to use here? Square root of, cosine is going to be square root of, and then tangent's going to be 1 over the other. Let's decide whether we're going to use plus or minus. All right. Alpha is between pi and 3 pi over 2. That means it's somewhere between 180 and 270. I'm going to talk in degrees because we're thinking degrees, right? So alpha divided by 2 would be somewhere between 90 and 135, which means alpha over 2 is in quadrant 2. In quadrant 2, the sine value should be positive, the cosine value should be negative, and the tangent value when we're all done should be negative. Now what? The sine rule was 1 minus, what's the value of the cosine? I'm trying to scrunch this in here. Cosine is negative 4/5. Okay. I don't know how you want to do this. You want to simplify the top, or you want to multiply top and bottom by common denominator? Common denominator? Okay, what's the common denominator? 10. By the way, minus the negative becomes plus positive, right? If I multiply top and bottom by 10, I have 10 plus 8 divided by 20. It's all under radical. 18/20 reduces to, okay. I don't think I've ever done it by multiplying by the common denominator before. I just did 1 plus 4/5 is 5/5 plus 4/5, which is 9/5. Divided by 2 is 9/10. Okay, so we got the same thing. Square root of 9 is 3. Denominator is square root of 10, so we have to do some great fun. We get 3 square roots of 10 over 10. What changes on this one? Yes, it's 1 plus the cosine, which is actually a negative 4/5. Can we just simplify that this time? What's 5/5 plus negative 4/5? Right, 5/5 is 1. Everybody okay? Well, you can do it on your calculator, guys, the whole thing, except for the square root. 1 plus negative 4 divided by 5, enter, divided by 2. Math, enter, enter. You should get, this would be 5/5 minus 4/5 is 1/5 divided by 2 is square root of 1/10. What's the square root of 1? So 1 over square root of 10 rationalizes to square root of 10 over 10. Does anybody know what the tangent's going to be? Oh, wait, what did I forget? Yeah, it had a negative. Don't forget the negative. I should have been carrying it all the way through here. Anybody know what the tangent's going to be?
One of 3 of these equations, I mean.
Anybody get it? It's going to be the sine over the cosine. I'm going to be lazy and say it would probably be faster if we did this. It's supposed to turn out negative, so let's just... That's the sine before I rationalized it. I'm dividing it by this. The cosine before I rationalized it. You can put in the rationalized one. Doesn't matter. It's all going to cancel anyway. What happens when I flip it over and do some canceling? Guys, think about it. If you put 3 squared to 10 over 10 divided by 1 squared root of 10 over 10, the square root of 10 over 10 is going to go away, and you're just going to have 3, right? But there was a negative on the bottom as well. All right. This section, first of all, this is supposed to be an x. That was a typo. These are just use your sheet for a trade. I love these. These are fun to me because I'm a little sick, right? Can you find something with a sine, cosine, plus cosine, sine on your sheet? What does it say on your sheet first? Where does it say sine times cosine plus cosine times sine? Everybody find it? Sine A plus B. So this is our A and this is our B. So the answer is sine of pi over 2 plus x. Find cosine squared minus sine squared on your sheet. Only instead of theta, we're supposed to write that beta thing. Yep. Anybody find that mess? Tan minus tan over 1 plus tan tan? In my mind, these are just all about familiarizing yourself with the sheet. Okay, what about this one? 2 times a sine times a cosine. It's a sine of 2 theta. But what is our theta this time? 3x. So it is the sine of 2 3x's, which is sine of 6x. It's about as tricky as they get. Whew. Wasn't really that bad, right? Do a couple more. Where's this one? It is the cosine of theta over 2, but what is our theta? So it's the cosine of 4 alpha over 2, which would reduce to that's a 2 and an alpha. Sorry, looks like a 22, badly written. All right, sine, cosine minus cosine sine. Is the sine of A minus B on our sheet. The A and the B's are 30 and 40. What is 30 minus 40? And with a sine, what can you do with a negative? So it's the opposite of the sine of 10 degrees. Last one for the day. Cosine, cosine plus sine, sine. Cosine, cosine plus sine, sine is? Okay. And what is 1/3 minus 1/4, guys? Cosine of pi over 3 minus pi over 4 is pi over 12. All right. Those aren't hard, right? And that's a big chunk of tonight's assignment on page 352 is just that kind of simplifying stuff. This is at the bottom. You need to use the stuff from yesterday to finish 7B.